integrated rate law for first order reaction. For example, reactant convert into product. In this, initial T equal to 0 time, reactant concentration I want to consider R naught and product do not form, therefore dash. T equal to some T time. At this, concentration is R naught minus X. X is a decompose or decay amount. Then here X moles form with respect to stoichiometric coefficient. Now this is R naught minus X is equal to R at T time. Reactant concentration at T time is equal to R naught minus X. This is at T time. Now rate is equal to, or rate is directly proportional to reactant concentration power 1 if it is a first order reaction. Anyway, we are discussing first order reaction, that's why first power. Therefore, we can say that rate of reaction is directly proportional to the first power of reactant concentration, that is called first order reaction. Now rate is equal to proportionally removed mean we can place the constant, therefore K, and reactant concentration power 1. This can be written as rate is equal to minus d R concentration by dt is equal to K R concentration power 1. If you write 1 R without 1 also, that is 1 we are considering, that's why R concentration. Now separate the terms, minus dr concentration by R concentration is equal to K into dt. Now this R comes here, this dt comes here. Then this equation multiply with the negative sign, then you will get minus into minus a plus, therefore d R concentration by R concentration is equal to minus K dt. Now integration on both sides, this is the integration symbol, integration on both sides, then we will get integration of dr concentration by R concentration, limit R naught and R at T time is equal to minus K into dt, its integration time 0 to T time. Now integration of dx by x, this is x1 limit, x2 limit, then we will get ln x limit x1 x2. Then this can be written as ln x2 upper limit minus ln x1 lower limit. This can be written as simply ln x2 by x1 log a minus log b represented as log a by b. So that also, if you want, mean log a minus log b is represented as log a by b. Therefore, I wrote this is in this format. Now, these are the mathematical formula. Based on this, this can be written as ln or not concentration, one minute, or at t time concentration by r not concentration is equal to minus k into t. Otherwise, this can be written as ln r naught concentration by r at t time concentration. When you reverse this r naught by r at t time, you will get minus sign is equal to minus k into t. This minus minus cancel. Therefore, we can write this is ln r naught concentration by r at t time concentration is equal to k into t. Based on this equation also, one more possibility, that is ln r at t concentration, ln r concentration at t time is equal to minus k into t plus ln r naught concentration. That also we can write. Based on this, we can get one graph. Y is equal to, this is called mx plus c. Then here one graph we will get, that is ln r at t time concentration, and this is time. Then what is the answer? This is on y axis, this is on x axis. Then according to this is a straight line, this is a downward, like this. This is called intercept. That intercept is ln r naught concentration, and slope is minus k. So according to our previous equation, what we got here, ln r naught by r at t time is equal to k into t. Now ln meaning a log base e form, that will be converted into log base 10, mean multiply with the 2.303 log base 10. Therefore, now 2.303 ln convert into log base 10 form, multiply with the 2.303 log base 10 form, r naught concentration by r at t time concentration is equal to k into t. So now k is equal to, when t comes in the denominator, then 2.303 divided by t, and this is called log R naught concentration by R at T time concentration. This is a final equation for first order rate constant. So now in this, K is equal to rate constant, and second one, T is equal to time. R naught is the initial concentration of reactant. R in textbook, R only is there, that is meaning R at T time concentration, that is concentration of reactant at time T. This is a final equation. So based on this equation, also we have another graph. What is ln R naught by R at T time is equal to K into T. Then we have here y is equal to mx. Then graph is ln R naught concentration by R at T time concentration, and here time. This is directly proportional is there, therefore like this increase. Then what is the slope? Slope is equal to m. This is a slope. So m is slope, the m equal to k. That's why the m. So that equal to here k. Now from the previous one, we have one formula. Last one is ln r. It means r at t time by r naught concentration is equal to k t. Here minus. Otherwise this equation only consider, but this is reversed form. When you reverse, you will get the minus sign right side. That is actually left side, but that we can send right side, then you can convert to minus kt. So this formula can be written as, this is which one form? Log base e form. So now I am writing this as log base e form. R at T time concentration is divided by R naught concentration is equal to minus K into T. This can be written as log R naught, not R naught, R at T time concentration by R naught concentration is equal to e power minus k into t. Why it is represented like this means, one mathematical formula is log a power x is equal to y mean x is equal to a power y. So based on this formula I wrote this is a equation. So now from this equation what we'll get? R at T time concentration is equal to R naught concentration into e power minus k into t. Now this R at T time concentration is known as R naught concentration minus x. In the starting equation I given, this is when reactant converted to product, initial is R naught, after T time concentration is R naught minus x. Therefore now this is R naught concentration e power minus k into t. Now R naught concentration, x taken right side, then this right side term comes left side, then R naught concentration into e power minus kt is equal to x. Then R naught taken common, then R naught into 1 minus e power minus k into t is equal to x. Then degree of dissociation can be represented as in zero order already I given, that is x amount is decay or amount decomposed by initial amount, that is called R naught. Alpha is equal to x formula now only derived, that is R naught concentration into 1 minus e power minus k into t divided by R naught concentration. Then this will be cancelled out. Then what is left now? Alpha is equal to 1 minus e power minus kt. This is what is that? Alpha means degree of dissociation. Then this is a formula for first order degree of dissociation. So finally, whatever we got, that first order rate constant formula is k is equal to 2.303 by this is a time into log R naught concentration by R concentration at t time. This is actually represented in another form is, that is k is equal to 2.303 final time minus initial time log final time respective, that is R at t time, initial 0 time respective R naught. Therefore, if 0 time not there, any other time between the t equal to 10 second and t equal to 20 second may be given. That time this can be represented as k, otherwise at 2 given time. This equation can be represented as k is equal to 2.303 by this is the final time, therefore t2, this is the initial time, therefore t1 log this can be represented as R1, therefore R1 concentration. This can be represented as R2, therefore this is called R2 concentration at 2 given time. This is about the rate constant at 2 given time, 2 different concentration. Now rate constant unit. This rate constant unit is, now this term is time, therefore 1 by second, and this anyway log in that units are not taken, if taken also these are cancelled, and therefore this can be represented as second inverse or minute inverse, or hour inverse according to what unit given in the question. This is a first order rate constant unit. Next, what are the examples? Example for first order reaction. that is 1. All radioactive decay reactions. These are example for first order reaction. Second one, growth or decay of bacteria. Growth or decay of bacteria. Third one, inversion of cane sugar. Sugar formula C12H22O11 plus water in presence of acid. This will be converted into C6H12O6. One is glucose, another one is C6H12O6. This is fructose. Then fourth one, acid hydrolysis, that is called acidic hydrolysis of ester. This can be represented as CH3COO C2H5 plus water in acidic medium. This will be converted into CH3COOH plus C2H5OH. Next, fifth one, benzene disonium chloride C6H5N2Cl is plus minus. This will be decomposed to give, that will convert into C6H5Cl plus N2. Another one, sixth, that is called N2O5 decomposed to give 2NO2 plus half O2. Then seventh one is 2H2O2 is gives rise to 2H2O plus O2. Now, half-life. Half-life meaning what is that? It is represented with the T half or T 50%. Time required for 50% of the reaction gets completed. Now, this can be, time can be represented as T half or T 50%. And next, R at T time concentration is represented as R naught concentration by 2. Why this is R naught by 2 mean 50% of the reaction complete, mean 50% of the reactant left. So initial how much? R naught. This is called 100%. Then how much left now? Left amount is 50%. Then 50% represented which one? R naught into 1 by 2. 50% left. That's why it is R naught by 2. Now we can place these. Substitute in equation. What is the equation? K is equal to 2.303 by time log R naught concentration by R at T time concentration. Now substitute here. K is equal to 2.303 by time place we can write T half. Log only. R naught concentration, R naught concentration. R at T time concentration can be represented as R naught by 2. 2 goes in the numerator. R naught by 2, 2 goes in the numerator. Therefore, now this one R naught cancel. Then K is equal to 2.303 by, otherwise I will take this one left side, T half taken left side, and K will be in the denominator. Log 2. Log 2 value we know that. So this is 2.303 by K. Log 2 value is 0.3010. On multiplying these 2.303 and 0.3010, you will get T half is equal to 0.693 by K. This is a half-life formula. Now, in this formula, concentration of reactant term is not present. Therefore, T half is constant. It do not depend on any concentration of reactant. Therefore, we can draw a graph here, time, that is T half, and reactant concentration, that is constant, do not depend on concentration of reactant. Therefore, R naught concentration, it convert into R naught concentration by 2. This is convert into R naught concentration by 4. This is convert into R naught concentration by 8. 8. So this is one half life, second half life, third half life. In this 100% come to 50%. For example, time taken, example purpose only, time taken is a 10 minute consider. Then here also 10 minutes, here also 10 minutes. Why? It do not depend on the reactant concentration. Every time taken for half conversion is equal. That is simply represented as one box. In this 1, 2, 3, 4. 4 reactant molecules are present. So this will be converted into 2 reactant molecule, mean half converted. Then for this time taken is equal to T half is equal to, for example, 2 seconds. Then this will be convert into half. In 2 half how much? 1. So that is 1 converted. Then here time taken half conversion is how much? 1 or 2? 2 seconds, because it do not depend on initial concentration. Then the time taken for this one T is equal to 2 seconds plus 2 seconds, how much? 4 seconds. Like this we can understand the half-life is not depend on the reactant concentration. Now, lifetime. In the lifetime, time required for 100% of the reaction gets completed. Therefore, T is equal to represented as T 100%, otherwise T lifetime. Similarly, R at T time concentration is completely converted into product, that's why 0. Now put into the formula, time is equal to 100%, directly I am writing, is equal to 2.303 divided by K. Log, what is that? Initial concentration R naught, and this is denominator is 0 because R at T time concentration is 0. Then what will happen when you divide with 0? That is infinite. log infinite value is infinite only. Therefore, infinite into 2.303 by k, I will write here 2.303 by k. And this is infinite. Not defined value is nothing but infinite. Therefore, infinite into that value infinite. Totally what we are getting infinite. So T 100% lifetime is infinite, means reaction never complete. Based on this, what we can say, the reaction, which reaction? First order reaction. First order reaction never complete.